Okay guys, so I started recording a session, so we can just start and let's see whether others can join or not. Okay, so let me just share my screen and please anyone just confirm. Wait. But you can see my screen, right? Just can anyone confirm? Can anyone just confirm whether you can see my screen or hear me? Yes. Okay. So let's just start the session. Right. So today is week 7. So this so earlier week we started with recursion, right? Recursion and how we can use a function to call itself, right? And we found that recursion is not always the good idea, right? Because it can cause the stack to overflow, right? Because the active records are like until the end of the recursion, the active records are kept in the stack, right? So that's why using recursion is not always the good choice, right? These things you remember, right? And then we practice some of the like normal simple questions which you can solve with loop as well as recursion, and found out that okay, recursion has some limits, right? And loop doesn't have that, because loop doesn't use any like dynamically allocated memory to compute something, right? Okay, and then we started with classes. So today we'll be like practicing some like use case where you can apply class and learn some basic concepts about Python classes. Okay. 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 So, so I guess you already remembered this diagram that okay, classes have their own data types. So basically classes you can think of it as as your own data type. Okay. So just like let's say list, dictionaries and all, you can what you can do, you can store your data, apply some functions to it. Let's say you want to append a new data, right? That's a function that is associated with a list class, right? Similarly, for a dictionary class, you can let's say append a key and value pair, right? So so these type of functionalities, let's say append, delete and everything, these are associated with the data structure itself. So these are called member functions of that data structure. Okay, and how the data is stored, that is called the member variables. Okay, so let's say just like overview of two things that classes are comprised of. One is how they store data is by member variables, and how they give us access to the data is by member methods. Okay. Now we earlier, like last day we did a small like introductory like exercise for classes, right? Just created a ball class that we can set its position and color, and the position was set by a tuple, color was set by a string. Okay, we didn't do anything else on that, right? We just use that ball object to basically like understand how we can like associate a print statement with a class and all those things, right? We'll like revise them today. Now, for example,
So one query I have, what
yeah,
is the difference between class and function?
okay. So see, so functions don't have any memory, right? Functions, they take in operands and they compute something, output something, right? So so the general work of a function is it expects some inputs and it operates on them and then now give us some output, right? That's a function. Now classes are something else that stores data in it also. So they basically kept functions that can be applied on the stored data. Got it, right? So it's basically a package thing. So functions are basically stateless, so you cannot maintain a state, right? You have to, let's say, handle different data structures to maintain a state, right? But for classes you can have the data associated with a function. So basically data and functions both, if you combine both of them, that's a class. Okay.
Okay.
Whereas if let's say the data is not associated with the function, it's coming from some other source and the function is only operating on the data, right? Wait, let me just,
So you are saying a class has a predefined data.
yeah, wait, 1 minute. Okay. So so classes have their data associated with it. That's it. Okay, that's the difference. That classes have their own data associated with it as well as the functions that can apply on that data. Okay. Now functions, they don't have any data associated with it. You have to pass the data. So by the like by the definition, the difference is this. But in terms of syntax and all, you will see that function. So class is basically a wrapper to a function, which also associates a data with it. Okay, okay. These functions can be only applied to these data.
Okay.
That's how. That's
And for defining a function, we use def or
yeah.
def. And for calling a class, I don't understand the syntax of the class. Like it's underscore equal to
Oh,
main, then quotes.
yeah, yeah,
So
yeah. So
yeah, that
I'll
syntax I don't understand. For function, it's easy. Like just def and define the function then.
yeah. So
But for class, it's like
okay.
I can't comprehend it.
Okay, let me just explain it one by one. Okay, so we'll see which like what each like syntax mean if you are defining a class. Okay, okay. So let's just like like see the theory first so that we have a understanding of what class means. Like I think you already have a pretty good idea about it. That class is basically, see, car, right? Car have which data points that car have or properties. So so data is basically properties, right? Let's say for a human, the data are, for example, for a human the data are his height, weight, age. These are the data points, name. Okay, and the methods are that he can speak his name. Okay, these are the data, these are the methods that can be associated with a person, right? Because he can speak his name, he can, let's say, okay, and any other functions you can think of is he can walk, right? Wait, let me just, okay. So so he can speak, right? and he can walk, he can jump. These are the functions that are associated with that person. So the clear difference is data, which is the properties of that class, and the methods that are applied to that properties only. Okay. Now here is an example of that class, right? See, car is a class. It has some properties like what is the color of that class, color of that car, how much maximum speed it can achieve, these kind of things, right? And methods are let's say start the car, stop the car, these kind of things. Okay, or turn left, turn right. Okay, so objects are like real world objects things, so they have some properties associated with them, and you can do something with them. Okay, for example, see this Ford and Toyota, these are child classes. So basically they are also cars, but they are from different makes, so they can have some different properties. So some properties will be common. For example, bird, right? Bird is a class. So bird can have color, bird can have let's say weight, bird can have like legs, right? These type like legs are actually common for all the birds, right? Legs equal to 2, right? There is no bird that has legs equal to 4. So those are basically the properties of class, like bird class. But let's say a specific species of bird can have only red color, right? So that species is a subclass of the whole bird class. Okay, so let's say uh, like the migrant birds, right? Those are a subclass. Yeah, so these type of relationships are also there. So you can have a like let's say parent class. Okay, that's just like car is a parent class, and there are different mix of that car. Let's say Ford has a like car prototype, Toyota, other companies also. They are all have some similar properties, but they can have some extra properties as well. Okay, so this is what a like, parent class and child class relationship looks. So we'll talk about them later on. Just cover up the theory first, and then we'll go with the implementation and how to implement these kind of relationships in Python. Okay. Now car, see, like I told you earlier, right? The properties. So at properties are also sometimes called as attributes, okay, or member variables. So there are three synonyms to it: attributes, member variable, properties. Don't get confused with the like synonyms first. So the see here the attributes are fuel, maximum speed. They have like just fuel, what fuel it goes like petrol or diesel, and then maximum speed, how much maximum speed it can achieve. And the methods you can apply on a car, for example, refuel, get fuel, set speed, get speed, and drive, or let's say turn left, turn right, all those things. Okay, now let's see the syntax first, how we can define a class, or how. We'll go with very simple implementation first, so that we already know what are the properties or what are the functions, and then we'll generalize it. Okay, source. Week 7. Oh, sorry, we're not importing anything. So this is about classes. Okay, so let's just go one by one. So let's just define some functions. Let's just assume that I want to track some cars. Okay, and like how I can track a car, what are the parameters I have to keep. So let's say I don't have any information, or I don't have any knowledge about classes. I just have knowledge about functions and arrays, data structures like arrays, dictionaries, and all. Okay, now let's just implement a car, or I want to track multiple cars, their selling point, and let's say whether it is currently on rent or not. So two things, selling selling price, and selling price, let's say this is the property I want to track. Selling price is, let's say 20 something like this, and uh, it's on whether it is on rent or not. Let's say I have a rental service, okay, on rent or not. This should be a boolean, right? Let's say true. So I have multiple cards, their names are also with me. So let's say I have a name property as well, or model property, right? Which model of car I have, anything, Toyota, something like this. And so I want to track multiple, okay, capital true. I want to track, let's say I have a rental company, and I want to, I'll be selling cars as well as renting them. So I have to track all these details, which model it is, what is the selling price, and whether it is on currently on rent or not. Okay. Now if I have to track all those classes, how can I approach without a object oriented thinking? Okay, so let's say I want to keep track of a big list, right? Say my cars, and see, now you will be seeing what is the benefit of switching from functional programming or functional type programming to object oriented. Okay, let's just implement everything with functional first, because you already know how to use functions, how to track data, all those things. So my cars, now I have, let's say, let's just hard code them. Okay, so now Toyota, Indra, Tata, uh, anything, trees, or let's say alt. Okay, and the selling prices should be different. Anything, let's say I'm not keeping them realistic, I just have them as a random values. Oh, sorry, there should not be any. Okay, on false. So let's say these are my cars. Okay, now what I can do, I,
Excuse me, what do you mean by
yeah,
that true and false?
which one?
True, false, we are writing now. What is the purpose of that?
So it's a see. So the let me just have the problem statement here, so it will be clear. Problem statement means I have a car rental and selling company. I want to track if track the selling price, and if the sorry, if a car is already on rent, right? Because if it is already on rent, I cannot sell it, right? Right.
Okay.
So these are the two. So there are two constraints. Let's just write the constraints to constraints, right? So if it is sold, right? Let's just have another true false variable here also. Sold. Oh, sorry. Sold. False. Let's just have all of them false for now. Okay. Now if a car is sold, then you cannot print it. First constraint is this, and secondly, if a car is on rent, I cannot sell it. Now what I can also do, I can increase a increase the selling price of a car, right? I can also rent a car. 5. I can also sell a car, right? Let's just keep it sell price. The property is confusing otherwise, right? See, this is how, like at this point, if you don't use classes, this is how you will be supposed to storing all this data, right? Let's say I want to have this program in my machine and I am handling a car rental company, right? I will be storing my data this way if I don't use any other, like only functional programming, right? And now the functions associated with that data will code them now. Okay, so what are the functions that are associated with this data? These are the functions, right? So I cannot, so these are the constraints and these are the functions. So I can increase the selling price of a car, I can rent a car, I can sell a car. Okay, got it? Now, now let's define the constraints first. How what is the best way of implementing this? Def constraint. Okay. Now what is the constraint? Car. So this is one car, that one dictionary. Okay. Now action. This will be returning me whether that action is possible or not. Okay. So action can be only two things, sell and rent. Okay, so for example, I just by default I set it as sell. So if you, or let's not set default, so you can just write a dot string. So this is one thing you should know, this is how you write a dot string. So whenever so I'll show what does it like help with, right? So car is the car data and action can be to sell the car or rent the car. Okay, now just return something, return 1. Now if I define this like this function, see, it doesn't give me an error because I wrote this extra thing because it's a dot string. You can write with Python. This is how you write a dot string for a function. So what does dot string means? So if I just call the function, whenever I'm calling it, if I just do shift tab, this help window appears, right? So now this help window, you see there is this dot string I wrote. So this
This
is how,
doc string is same as commenting.
no, so commenting is for you. So let's say if I am doing some logic which is hard to understand for me, right? I want to remember it later on. Let's say I want to let my other friends understand my code. That's the commenting. But dot string is not about how you implement it. It's about like what can we do with the function. For example, let's say let's see another realistic dot string. Okay, import np dot array, let's say. Okay, see, this is what a dot string looks like. So create an array, that's the main or whole purpose of the function np dot array. And now what the parameters it took parameters like object array like d type, so data type what it took, copy, these kind of these parameters it took. And now what does it returns an nd array. So this is how you write a dot string. And also there is C similar functions like this, notes, some examples of how to use the function. And
Okay, so these will be displayed unlike
yeah,
comments, but
yeah,
they are not a part of the program.
yeah, exactly. So this is for let's say you don't want any like you want other person to use your function, so they can just do shift tab and know how to use your function. You can write a whole manual of how to use your function in this dot string. Okay,
Okay.
got it. Okay, now here I can write like this, parameters are car is the car data and action can be sell and car the rent. Now if I just Okay, so yeah, see, it shows parameters and then the two parameters it took, and what it returns. I can also write the return thing. Return, it returns what? It returns if the action is possible on the car. Basically, it's boolean. It returns a boolean, right? And it returns whether that action is possible on the car, when being selling or renting it. Now, how to implement it? So, what is the constraints? So, if the car is sold, then you cannot rent it. If the car is on rent, you cannot sell it, right? So, if the car data has this structure, right? The dictionary structure. Now, I can see whether it is on rent. I can see whether it is unsold, right? So, if the car on rent is equal to true, right? If it is on rent, then and if and car, no, sorry, not car, action is equal to sell, then it's not possible. So return false. Okay. Now if else, elif ladder, car sell, no, sold, key is sold, sold is equal to true, and action is equal to rent, then return true. Sorry, return false. Right? It's also not possible. And any other case, any other situation, you return true, right? So if these two returns doesn't work, then at the end of the function you return it true. So now the action is possible. So this is how we enforce the constraint. So these two constraints are satisfied. Now I can just apply, send a car, let's say send a car, my cars, this is a list, so I can send the first car, and I can see whether I can sell it. Yes, I can sell it. Let's see. Yes, it's sold equal to false, and rent is also false. I can sell it, but oh, I cannot sell a car twice. So there are other two things as well. So I cannot rent a car twice. I cannot sell a car twice, right? So I can just copy these two and paste it like this. So rent and on rent, then also return false. Sold and action is also sell, then also return false. Okay. So now I can also rent it. Yes, I can rent it. Now let's see whether I can rent this one, the car 1, right? Not 0, car 1. Car 1. No, I cannot rent it because it's already rented. Whether I can sell it? No, because it's rented. Okay. Now this is one how you can enforce the constraints. Now let's just implement these functions too. So what are the functions? Now one function is done. One thing I have implemented. Now the functions I have to implement it for my company. Okay. Okay. Now I can increase the selling price of a car. So how I can do that? So def increase. Okay. So what I have to pass? I have to pass the list, my cars, and I have to pass the car. Let's say the model, right? The model I want to increase the name of. So I have to also pass the model and the price, the new price. Sorry, or let's say increased or increase. How much increase I want? Okay, let's say it can be positive or negative also. So I can also decrease. So increase, like change, or um, or let's just keep two different functions, increase and decrease. Okay, we'll also do some checks So these are some cool tricks you can apply when programming. So you can just catch any errors. Let's say you are not supposed to pass negative values, so you can enforce it in the function. So if someone pass a negative value, they will get an error. Okay, so we'll see how to do that. Decrease. So do two function, increase, decrease. So I can also rent, right? I can also sell. So these are the four functions I have to implement. Now model. So for every car in my cars, basically I will be enumerating it. Enumerate, you know, right? Or I have to explain? Can anyone just confirm whether you guys know enumerate or not? I have, maybe I have touched it sometimes earlier. So see, enumerate is like this. Let's say you have an array, let's say string array of A, B, C, C and D. And now enumerate would produce a input like this: index, comma, string in enumerate string array print index, comma, string. Yeah, see, now enumerate will give you the index as well. Okay, to modify the let's say anything in the list, you have to also have that index with you, right? So it will give you the index. So here car and car index. So just limit something which I can understand later on also, car index. Now what I can do, I can search where my model match and then increase the price there. Okay. Or instead of yeah, let's just have two different functions for now. Okay. So we will first check whether uh, that increase is positive or not. So we can use a assert function, or you can use a raise call also. So if this is less than 0, then raise an error. So two approaches are there, one is assert and one is raise. So raise exception. So basically it throws error to the system that okay, something is not right with the inputs according to your choice, obviously. So let's just implement it with raise later on, or let's say we implement raise on the decrease function, implement like assert on the decrease function. So now if increase is less than 0, so that means it's negative, so we'll raise an error, raise exception, and then pass the string you want to display to the user, that this is the exception you got. Just like let's say I want to divide 1 with 0, you see this exception, divide 0 divide error. So this is what an exception means. Okay, and it shows division by 0, so this is the string. Now for my case, I have a general exception, so it will not show division by 0, something, it will show an exception colon and that the string. Okay, so string would be increase cannot be negative. Okay, now it will, if the increase is negative, it will throw an error. Now I have to change the increase, so I have to increase the car price. So I have to find if my car model is equal to model, right? Then I have to break out of the loop. Now I have the index of that specific car which I want to modify. I can just do like this, my cars, and then modify it, car index. And I have the car, uh, what was the sell price, right? Sell price, yes, sorry, plus equals to increase. So plus equals to a shorthand of a equal to a plus 1. Okay, something like a plus equal to 1 means a equal to a plus 1. So we just increase the sale price with this increased factor and just do return something like that, or just don't return anything. Okay, it just increased my uh, the price of that car or that list. Okay, similarly I can just copy this function, paste it here. Now decrease. So decrease cannot be negative as well. So I want to decrease, let's say 10 rupees. So that would be minus from my current price, right? So decrease cannot be negative. Now here instead of raise function I can use a assert. So assert is what? So assert is if the condition is true, okay, then it will assert, I guess. Let's just apply it and see. Assert, and then you have the condition. So decrease is equal to so decrease should be greater than 0, and if it doesn't work, so if it is not greater than 0, then this statement will be executed, this error will be executed. So decrease cannot be negative. Okay, let's just check once, we'll see. Decrease is equal to 10. Sorry, I have some name issue. Yeah, so see, now no error happens. If I have minus 10, it gives me assertion error, decrease cannot be negative, something like this. Okay, so yeah, decrease cannot be negative, so it should be positive, otherwise it will show an error. Now if my car, I found the car, I break out of the loop, I have the selling price, now I will be minus it from the previous selling price. Okay, now rent and sale, here I have to enforce the constraints. So I will check if constraint and then constraint take what? Constraint take a car object. Okay, so constraint take a car dictionary, right? So what I can do, I can just find which same code, exactly same code, I just copy it from here to find the exact car data, right? I have the car data now. I can just pass it here, car comma action is rent, and sorry, here I have to remove these two. Okay, and if it is true, so if it is true, then I will rent the car. So my cards, car index on rent is equal to true. Okay, if it is rentable, then I will be making it true. So next time it is not rentable now. Okay, so if I go and rent a car 2 times, it will show me an error that it's not possible. Okay, and let's see if it is false. If it is false, then else what I can do, I can just raise an exception, right? Exception showing key this car is just also print the the actual data. This car is not, let's say, is already on rent or sold, right? And rent we have implemented here, just copy it and paste it for sale. It will be similar logic. I have the car, this action will be sell, and if it is true, if I can sell it, then the sold key would be true, otherwise the car is already on rent or already sold, right? Same exception. So these are the functions I can apply on the car. So up to this everything is fine, right? How we have, how we are managing the data by a list of dictionaries, and how we are applying or basically manipulating the data. Up to now everything is clear? Oh wait, here we have to, in the assert call it should be comma. Yes. Now let's just see. So I have the all data already populated here. I want to say, let's say my cards, right? Or just do a UI type of programming. While one, that programming we did like the first 2-3 weeks, right? That we can take input from the user and then just ask him to whether you can continue or not, right? So you can just do like that. Here print cards, sorry, carpool, and then I can print my cards. Now what are the inputs I can take? Input, sorry, sell or rent, two things like, or increase, decrease, right? These are the inputs I can do. So this is action. Among this I have to select something, right? And then after that, if action is equal to sell, I will do something, elif action is equal to rent, I'll do something later on, right? Elif action is equal to increase, sorry, I'll do something else, elif action is equal to decrease, so I'll do something, and else if it's not none among them, then just raise exception, or not raise an exception, print invalid input. Okay, now see here, if I sell it, what will be the, like, what will be the next question, right? Model, the model I want to have it take input from the user, right? So input model colon. Now I have the model. Now I will call the cell class, just my cell class. It's a cell function, cell my car and the model I chose. Similarly, for the rent also I have the same things. So we can just merge, or oh sorry, no, we cannot merge it because the rent function here, rent is different. Rent my cards, right? Now decrease. Now see, one thing is common for all the things, right? This model parameter is common, so we should just keep this input out from here, just keep it outside the whole if block. So we have the model inputted, just that's by default. Okay, so sell my card, sell rent, decrease. So decrease would be, now I have to prompt for an what I have to prompt for the decrease or increase, right? So increase is equal to, it should be integer, let's say integer input increase in rupees. Okay, same copy paste it for decrease, decrease. Now I have the functions with me, increase, it takes all those things increase, my cards model and the increase, so INC. Similarly decrease, it takes these things and decrease, otherwise it will just do a print invalid. So all my functionalities are programmed now. Okay, so I can just run. So this is my carpool. I can just do a formatting and print it in a good way. Okay, so instead of pulling like printing the whole dictionary, what I can do is I can like do a table type of printing. Okay, um, we can always do that. Let me just do that instead. So I have to import a library and just ignore it for now. I'm just doing it for understanding this. Okay, pd dot data frame. Yes, now see. So I have the carpool. Oh wait, /n. Yeah, so I have the carpool like this. Toyota, Mahindra, Tata, Mercedes and Alto, and the selling price on rent and sold. All those things are in an organized printing format. Now let's say I want to sell this Mahindra, this model, right? I want to sell. What is the model? Mahindra. See their exception. This model is already on rent or sold, is already, so it's on rent. Yes, it's on rent, true. So I cannot print it, right? So you see this error, this exception, it actually closed the program. But let's say I don't want my program to get closed. I want to let's say just print the exception and carry out the while loop, right? Carry out the UI part, that okay, take the next input from the user. Now to do that, see, these are all small blocks you are learning along with like how to implement these things on Python. Okay, so this is how you do. This is error handling part. So let's say error happens, and that error may happen multiple times for some inputs, and you want to catch it. Let's say whenever you have that error, you process the input by some other means. So this is try catch block. So that, so where I can have exceptions, see, here also I can have some exception. Here is also an exception. Here is also, so every damn function have an exception. Okay, so for all of them, what I can do, I can just put the whole thing on a try catch block. So if everything, any of the things failed, this except block will be called. So try will be, so basically the block means try this whole block, try to execute this whole block. If anything fails, go to the except block. So one of the use cases are like this. Let's say you want to open a file, okay, open two files and write something like or get some, read some data from file 1 and write to file 2. Let's say you open two files and one file somehow it doesn't open. Okay, so you have to close the second file too, right? So because that file is already open, so you have to safely close it, otherwise the data may get corrupted. So in that case, whenever the exception happens, the control flow goes to the except block. There you close all the open files you already have, so that because of the exception, no data gets corrupted. Okay, so similarly we can do here. So if anything happens here, we just catch the exception as except, sorry, let's just cap exception e except exception as e. So e will be my exception variable and just print e. So that message will be printed. Instead of getting out of the loop, it will just print it. Let's just try it. Sell, I want to sell that Mahindra Mahindra. Okay. See, now it doesn't get an error, but it says, okay, this model is already on rent or it is sold. So you can see that it's already on rent, so you cannot sell it. Right now, let's let's just try to sell what we can already we can sell actually. So let's say this Toyota model, right? We can sell it because it's not on rent, it's not sold yet. So sell TOYOTA. Yes, so it is successful, and now see the Toyota model status is true now. So it's sold. Right now, if I want to rent it, it will throw me an error, right? So it's not possible because you already know we have the constraints in place, right? For example, let's rent the Alto car. Okay, so I want to rent the Alto car. Yes, it's already rent. See, rent. Now let's say I want to increase the price of this Tata model. So increase model is Tata, and let's say the increase is how much is the price now? 3 something, right? So let's increase it by 100. Now see its price is increased by 100, right? Similarly, decrease Tata, and let's say I give decrease as a minus value for some reason, right? It see decrease cannot be negative. So the constraints are there, they are kind of acting together to have this UI to make this UI robust. Okay, so any questions till now? Guys, so this is how you will be implementing a car managing system with functional approach, right? Okay, so now from this approach, what is obvious is we have to keep the data separate, and we have to keep the functions and everything separate, right? We have to basically pass the whole data whole data to that function, so that we can just process, find which car I am talking about, and then update it, right? The data and the functions are not associated, so they are segregated. We have to pass the data every time I'm calling a function. See, whenever I'm selling, or let's say increasing the price of a car, I'm just sending my whole data structure, this my car data structure, right? This data structure. Okay, so it basically uh, what it basically trigger like um, what happened. So you have to move the whole data structure for executing on a function, right? So the memory movement is big. So let's say the car list has thousands of entries, then that whole data structure would be copied so that it can be looped and accessed by um, right by that function and then update. So basically a lot of memory movement is happened. Okay, now let's just do it in a class or like object oriented way, so that we can reduce the memory movement. We can just cherry pick which object I have to interact with, and the functions will be associated with the objects itself, and the data is also associated with that object, not on a separate big list. And the functions are not let's say associated with the function. We have to always send the whole or big data structure to that function. Instead, what we can say is the functions and the data at together, so that we don't have to access the whole data structure. We can just have access to one car that would give me access to sell, rent, or any operation on that. You get the point, right? Or any confusion till now? Just mention it now so that I can repeat some points. Guys, anything you want to mention? Okay, so I am moving along. Uh, Okay, so this is how you implement it in a functional approach. Now the same problem can be implemented in terms of a object oriented approach. Okay, now we have the object oriented solution. So we'll see the syntax first, and then we'll try to implement or try to have all those constraint properties and everything with the with that class. Okay. Okay, let me just see whether, yeah, it's recording. Fine. So what are the properties we have? Let's see the data structure, or let's just copy, or let's just print the data structure there. My cards. Fine. Now the properties are model, so let's just write it in an informal way. Properties are model, sell price, on rent, and sold. These are the properties, and functions, or what I can apply on them. I can do, let's just, I can do what, increase, or let's say sell, rent, increase, decrease, right? And the constraints are always there, obviously, under constraints. So this is the whole like kind of rough of that problem, right? So these are the properties a car should have. I should be able to do sell, rent, increase, decrease of the price, and under some constraints I can apply these functions, or I can do these things, right? Now the syntax, let's say, so it's something like this structure would be similar, right? So class, so this class is a keyword. See, it's already colored in green, so that means it's a keyword. Okay, so you cannot name a variable class. Okay, so car, let's have the class as car, and the general nomenclature of a class is it should be capitalized. Okay, so the first character should be capital. So that's how usually people name like classes, and this is the colon. Now for function, the syntax looks like this: def, then the function name, right, then parameters, and then something you want to do, something, just write it, something want to do, and then some return some result. This is what a function looks like. Now for a class it looks like this. Class is the like similar def, similar keyword for class is class. Okay, now the class name, any parent class. So we'll not talk about parent class for now, because parent class by default a class has object as a parent class. So object is a default function, default object in Python. So everything you are using, integer, float, list, dictionary, everything is a object type. So basically everything in Python is a object, right? So by default it's object, its parent class is object, but you can pass any parent class too. And by default the parent class properties and methods will be copied to the child class function. Okay, so whatever parent class you have, any properties or methods, you can always find it in the child class without even implementing them. Okay, now we'll talk about them later on. Just for clarity, or basically like theoretical understanding, we'll just discuss the whole structure of a class. Now first function, sorry, First function should be constructor. Constructor means these are all informal. Okay, it's not how you write it. I'll show how you write it. Actually, just put them as comments. Constructor, it executes when a car object is instantiated. So what is an instance? Instance is basically a car. So just like list is a class, and a list which is having 1 2 3 4 as a value is a instance of that list. Okay, is an instance. So basically, just like human is a class, and we, let's say me, right? I am an instance of a human, something like that. So that's the difference between a class and an instance of a class. Class is basically a formal definition, and instance is basically a or basically a object in memory, which have the similar properties and methods as defined in the class. So you can just so for memory, you can just human is a class, and let's say John is a instance of human. Okay, now first function should be constructor. So it executes when a car object is instantiated. So let's say I want to create John is equal to human name John. Whenever I call that, it will execute the constructor. Okay, now constructor, you can define properties. For example, properties are usually, not always, defined in constructor. Okay, so how to define properties in Python, we'll see. Then
So an object is a function.
object is a
Is it a function?
no, object is a formal definition on it. Sorry, object is an instance of a formally defined class. Okay, so just like see this John is an object of a human class.
Okay.
Just like let's say Billy is an object of a cat class. So cat is a class. So there can be multiple breeds of cats and everything, right? But Billy is one cat. That's an object. But so it's an object of the whole cat class. So classes are formal definitions. Okay, and the object is basically a so get my point, right? So it's basically so human, it's written what are the properties of a human, what human can do. This is, let's say, written on somewhere. That's the class of human, and we are the humans. So we are instances of that class.
Okay.
Okay, now properties are usually defined in the constructor. So all the properties you have, those are defined on the usually defined on the constructor, but later on you will see you can also define it anywhere else in the class in Python. But for other programming language, there are sometimes restrictions. So you have to define it in a like outside of a function, but you can define any parameters inside of a function too. Later on we'll see. Okay, so properties are usually defined in the constructor, and now you can also write some methods to work on the properties. So what are properties? Properties are basically data. Properties are basically data. Okay, so this is a general or a theoretical understanding of a class. So, and this is what functions looks like. So what is a method? Let's just have a dummy method. Method name. Method name. See, function method name is similar, right? but it's actually indented under the class keyword. So under that class there is a method which takes some parameters and output do something. So do something with its data, return results. Okay, and data are, so these properties are defined in the constructor. So constructor, it is also a function. Constructor function, it takes some parameters, it defines some parameters, it takes some parameters, it defines some properties. So here let's say just write define properties, return, just return. Okay, we don't return any, we specifically don't return any object from it, we just return from that constructor. It has a void return type. Okay, but it can return any result. So just to make sure return some any other thing doesn't happen, we just don't write the return statement after constructor. Okay, and there is a special parameter that is given to all the class members, that is self. So just remember it for now. As we progress throughout this class, the use cases of classes and all, we'll see what this self mean. Okay, so for example, just remember that there is a constant parameter self. Even if there are no parameters, the self should be there. So let's say I have another function, another method that name method2, method name 2, which doesn't take any parameters. So I will just write it like this, something, return some result. Okay, now so this is a kind of pseudo code, right? Now let's see what is an equivalent, equivalent clear. So let's see what an equivalent code in Python. So I have to make this car class, right? So the properties are already defined. What I can do is also already defined. So let's just code it. Class car. Now I have to write the constructor first. Constructor, and also define the properties. So how to write it? See, remember now, def underscore underscore init underscore underscore. This is a special function which is the constructor. Okay, so the constructor function is named as underscore underscore init underscore underscore. This is the constructor function. So by default it will took a self, and what are the properties I want to set? These, right? These are the properties I want to set of that car. Let's just indent them properly. Now to make them as a properties of that class, we have to write self dot self dot self dot self dot. That means it's a properties of self. Self is that instance. So whenever you will be creating an instance, that will be treated so in its own. So it will treat it at itself. So that's the self. Okay, so basically this is how a instance referred to its parameters. So it refers to its parameters as self dot parameter, matlab apna parameter, something like this. Okay, now self dot model self. So now we have to also get data from outside, right? So for that I can pass them as parameters in the init function. So I have three things to set or four things to set. Name, sorry, model, I can just name them similarly, or I can, for just to avoid confusion, I can name them differently. Name, sell sp, let's say sell price, comma on rent, comma sold. Let's say these are the parameters I want to send. Okay, and model should be equal to name, sale price should be equal to sale price, rent is equal to on rent, and sold equal to SLD. Now this is how the parameters are set. So when you will be creating an instance, I have to pass all those things. See, now let's see. Car, I had to create a car, call. This is how you create a object in a object in from a class. So the object, the how to instantiate, let's just write it here. Instantiate from a class. How to instantiate? Object is equal to class name and then parameters, the parameters of the constructor, except thus except ignore the self. So देखो यहाँ पे 1 2 3 4 there are only four parameters I will be passing, not the self. Actually there are total 5 parameters, 1 2 3 4 5, right? But this self is an special parameter, we don't have to pass it. Okay, so that's what Python internally tracks to associate a instance with a class. So we don't have to handle, or we don't have to see how we are passing self. We will just pass these 4. Okay, and if I am just, let's say, using this car and shift tab, it only show me the 4 parameters I should pass. It doesn't even show me self, right? So just let's paste it, pass them as Mahindra SP, let's say something random, on sold false, true. Now this is a car object. Now it's funny, see, whenever I am implementing it as a dictionary, see my cars, I have that whole dictionary list with me also. If I just write 0, you see this is how nicely it's get printed. It's printed as a dictionary. So now let's say I want my cars to be looking like this. This car class should print something like this because it already have the data. You can check it. Let's say car, small car, or let's say C1, right? C1, if I print it, it looks something like this. But if I want to access it, let's say model. So this is how you access the data. Car1 dot model. So now the name is printed. Car1 dot selling price. Now its selling price is printed. On rent, its on rent is printed. Sold, its sold is also printed. See, sold, we set them as true. So this is how you access the attributes, the data. Okay, just like here, let's say for car 0, I will be accessing model name with model, something like this. Okay, now I want my
I
car.
have one more query now
Yeah,
based on what you are showing. Like, so the libraries in Python we import, they are the same as classes.
exactly, exactly. So
Okay.
they're all implemented in a object oriented manner.
Okay, so we call them libraries. They are
Yeah,
basically classes of
exactly.
C,
So
C++.
so 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 not always classes, so they can be, so you can think of them as packages, right? So classes, so a library can have multiple classes inside it.
Okay,
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 so library is basically a bunch of functions and classes and everything that constructs a library. So for
okay,
example, this numpy library or pandas library I use to print out that whole dictionary in a pretty fashion, right? That package has lots of classes, lots of functions in it. I can use them for any manipulating any data. Okay, but anyway, all the packages you have, they all have associated objects, classes, and all. Okay,
okay.
so
Understood.
this,
Yeah.
yeah, so this is how you access the data in the class. Now let's say I want to print my, let's say if I print C1, this is how it get printed. It's not nice. So I want to have my data printed like this. So what I can do, I have a special function in Python, REPR. This is called representative function. So how you represent the data when you will be printing it. Same thing, this representation, representation function, and it takes nothing, only self, okay. And what you should return, should return a representation string. So it should return a representation string. Okay, so return, and then my string should, let's just format it, if, yes, let's say I want my cars to be printed like this. Now format would be uh, model is equal to self dot model. So this is how you access the data in other functions. So here you see you define the parameters or the like member variables. Now from any other function within that class, if you want to access model, you cannot just write model and it will be accessed. You have to write as you have defined here, self dot model. So the variable name within that class is self dot model. So basically अपना model variable, समझ रहे हो? This is how you access
So
the,
this like when we are writing def, then can't we write def in it directly? Why are we writing underscore in it underscore
yeah. So
like?
these are special functions. So this is how Python enforces it. So these are not your functions. So basically these are functions exported from Python itself. So these are special functions, right? When
So
we will be,
these were not defined in the class, but they are some inbuilt functions of
yes,
Python.
exactly. So these
So
are
this is the syntax for writing them like
yes.
underscore.
See, so by default everything is a subclass of object. So by default it is object. So now this object class, it, see, if I just do object, or hey, let's say dir object, I can see every methods in it. See, it has all these functions implemented: lt, le, init, repr, where is it, repr, everything, right? So by default any class is a subclass of object. That's why all of them has these functions in it. If you want to if you want to implement them, you can implement them directly like this. But my own functions, they can be any name. So we'll see how to name them. So I will implement all the functions we implemented here, right, earlier. So we'll see. So this is some special function, underscore underscore init, underscore underscore repr are special function. Okay, that basically it's a constructor, and this is the representative functions which is named by Python. So not so when so you are using Python have some constraints. If you name a member function as underscore underscore repr, it will be called whenever I will be printing that object. Okay, so now model self, no comma, um, let's just say self price is equal to self dot self price on rent is equal to self dot on rent, and lastly sold is equal to sold. So this is the whole representation I want from my function, right? Now let's just now see, this is whenever I'm printing c1, now that function get executed, repr function automatically get executed, and this is how you print my car. Now it's much prettier, right? Earlier it was like underscore underscore means something random thing, but still I can access my data points. Let's say model, its name is Mahindra. But if I want to see the whole data, it's not some gibberish now, it's something meaningful that I can work with. Okay. Okay, so these are two special functions you have to implement for your car object. Now let's just implement the other functions too. Okay, now what are the other functions? For example, first I have to implement the constraint. Okay, so constraint will just copy it from the top. Where is the constraint defined here? and we'll just implement it in the class itself. So basically the car class have its own constraint now. It doesn't depend on some other person to define that constraint. It automatically get associated with a car object. That those constraints. Okay, let's just press it. Okay, indentation is done. So I told you that okay, there will be a self thing, additional self thing. Now this is the constraints. Now we just fix what so constraints. So now I don't have to pass the car because the car is the self. Okay, that object self is the car. I can access its model, sale price and everything. I don't have to rely on the car. Now see, I was relying on the car to be sent by the user so that I can access it on rent and everything, right? But because this self already has the variables of an instance, I can that just use that. So instead of this, I can just do self dot. Okay, action I have to pass, obviously action is from user side, right? Similarly for all the other things I can also do similar. Yeah, self dot. Okay, so this is how you implement the constant function for that class. So whenever you try to do some action on a car object, it will do return true or false. Let's just see it in action. Okay, now I have a car object now, and it's already sold, right? So I can see whether I can sell it. Constant, and I have to pass the action sell. False, I cannot sell it. You get the point, right? Now the constraint function is associated with the C1, with the instance itself. Let's say whether I can rent it. It's already sold, so I cannot rent it. Okay, two options are possible: sold, sell and rent. So I cannot uh, sell or rent it because it's already sold. Let's just keep it as false for now. Whether I can rent it? Yes, I can rent it. Whether I can sell it? Yes, I can sell it. Let's just see whether if I keep it as rent, I can sell it. Yes, no, false, because it's already on rent. Okay, now the constraint is implemented in the class, car class, like this. Let's see where how other functions are implemented. Okay, other functions, where are they? Here. Copy all of them. Okay, I have my car class. Just paste everything here. Do an indentation correction. Wait. Yes, indentation is corrected. So everything, so all the functions should be indented within that class. Okay, now increase. How I should increase? See, I don't have to pass the whole data structure now because I have the. So why you are passing the whole data structure? Because I was passing the model name, and then I have to loop through the whole data structure to find that model, find the match, and then apply the function on it, right? So instead, because I already have the self now, so I already have the car which I am trying to act on. Okay, so increase, what I can change with, see, I don't need this. I can have the car class, whichever car instance I have, I can access it with self. Model name, we don't need it. We just need the increase. So we just check whether increase is negative. That check is fine. We already have the car, so we just check whether that increase is possible, and just do like this: self dot sell price plus equal to increase. You see the difference? So I already have that car with me in the cell. Whichever car I am trying to apply the increase on, I already have that car on the self variable here, and Python passes that C1, C2, any object as a part of this self. So self dot car sell price would only increase the price of C1 if I am applying C1 increase. Okay. Similarly, I can remove everything from here. Self, I don't need the model name now. I just have to self dot sell price. I have also the decrease class now. Now rent, I don't need the whole car object or the model name. I'll just call rent. I don't need the model name too. I don't have to loop through the whole data structure. Now see, the data migration is all vanished now. So I don't have to like, pass all the time the data, whole data structure, right? I have to just access a car and then just apply some method on it. So rent, I will check whether it is possible or not, and this I can apply. I don't have to send the car. I can do just self dot constant rent. Now it will check whether it's possible to rent it, and then if it is possible, then set its parameter self dot on rent is equal to true. Else it will throw an exception, and by printing this self, we can just print that statement exception. This self is already on rent also, so self will be printed as the represented here representation class. Or you can also do like this self dot underscore REPR if you want to be very much functional about this. So you'll manually call the representation class whenever this exception happens, or just by doing this it will be called also. Okay. Now sale, similar implementation. Self car ID, I don't need all of this because I already have the car in my self variable. Self dot constraint sell, and just self dot sold is equal to true, except you just print the self. Now all the functions are now ported to the class. You see, everything is now ported, and I can apply anything to my car. Now I can check whether it is sellable, false because it's on rent. Now I can also increase, see, increase, sorry, C1 dot increase, and I can send just let's say minus 10, right? It should say okay, increase it not, increase cannot be negative, because what happened, it goes there, it checks whether increase is negative, it just throws this exception, it cannot be negative. Okay. Now if I want to rent it, because it's already rented, if I want to rent it, rent, see, it throws me this all this car model is already on rent or sold, so it's already on rent. Now because my car class variable is implemented, right, the class car class is implemented, I can just copy the whole UI code I wrote here. Here while true carpool. Now carpool I have to define. Let's say I still want my carpools to be my car is equal to a list of cars. How many cars we had earlier? Let's just have the same amount of cars. Just copy paste the things from here. 1 2 3 4 5 1 2 3 4 5. First one is Toyota, and the on rent status is false. This is true. Mahindra, Tata. Copy this. Alto. Copy the prices too. Okay, now the status is false, true, false, true, true, and lastly true, false, 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 false. Fine. So everything is set as the, so earlier we set them as list of dictionaries. Now we set them as list of car objects. You get the difference, right? So this is where we define everything, the data parameters and everything in the init function, and everything you can do on that data is defined here: increase, decrease, rent, sale, everything. And we also have a representative class, so my data structure can be directly printed and it will be a meaningful output, right? Now I have the my cards list. Now if I just try to print my cards, it looks something like this: model, Toyota, all those things, and it's a list. Okay, now yeah, so I can just, instead of doing this pandas, PD, all those things, I can just print my cards. It's my car. Okay, sorry, my cards, not car. There are multiple cards. Okay, my cards, and then the change I have to do, action, it's still fine in model, fine, sale model. So after I have the model, I can just do something like this. Instead of model, I can ask him to choose the ID. Let's say my cars, instead of printing as a pool, I can do a for I in, sorry, index comma car in my cars, print index comma car. So it will print like this: 0 the car, 1 car, 2 car, something like this. And instead of model, I can just ask them to give the index. Okay, so this is the car index. Okay, so after I have the car index, I can directly access it from the list. So I can just get, instead of sending the whole data, I can have the selected car to be what, selected car to, and then just cast it to integer. Selected car is what, index, I already have the index, so my cars car index. Now I have the car object with me, right? Let's say the first car object or third car object. So I have that object with me, and now I can apply anything on that. So selected car, so action cell, then just dot cell. I don't need anything else. Selected car rent, so selected car dot, sorry, rent, increase. So I also have to get the increase amount. Now instead of passing the whole data structure, increase amount, everything, I can just do selected car dot increase, and in that I have to pass the increase, right? Because see, what was the variable? Yeah, increase and decrease I have to pass. Yeah, increase. Similarly for here, selected car dot decrease, decrease, and anything else is already there. Now let's just run it. What happened? Cannot unpack. Oh, sorry, I have to do enumerate, so that I have the index as well as the car file. See, carpool, my carpool is 0, 1, 2, 3, 4. These are the cars. So let's say, and let's say the object is to, so I have to sell a car, sell the car, and give the index. So what I want to sell? Let's say I want to sell the first car, but it's on rent. So let's see whether it works. Okay, I want to sell the next car. See, this car is already on rent or sold, so I get the correct error message, right? Now let's just see whether I can sell a car successfully. So this second one, so sell, I want to do the second index. Second index means this one. So it's not on rent, not on sold. I can obviously sell it. Yes, it's sold. So it doesn't print anything, so it's sold. So what we can do to give us a correct sell message, we can just, whenever sale and rent successfully occurred, right, I can just do print sold colon sell and just format it, right. And for sorry, this is rent, and whenever I am solding it successfully, it's a sold, rented, sold. Okay, just create the card instance again. Oh, sorry, my loop is still going on, just interrupt it. Update the see, after you change anything to the class, you have to update it. So I have to rerun the class again, create the whole list of car objects. So now I have the updated car objects that has that print statement in the sell and rent function. My cars are this, still the same thing. Okay, so I want to sell, and I want to sell the second car. Yes, so sold. Okay, and why that comma is coming? So I have this comma. Sorry, should not have that comma. Okay, anyway, get the point. Now let's see if that status is updated. Yes, the status is updated, it's sold. Now see whether I can increase or decrease the price of the third one. I want to decrease, yes, give index the third one. I want to decrease by, let's say, negative number, minus 10, minus 12. It will show me, okay, you cannot decrease, negative cannot be decreased. Similarly, decrease, same third one, and decrease by 1000. So it should be around 343134. Now it's, oh, is it unsupported operands for int and function? Okay, let's see what happened. What does the error happen? Unsupported operand for string and function. Sell price. Oh, okay. Unsupported operand types for minus equal to int and function. What happened here? They're saying this. Oh, sorry. This will be decrease, right? Or actually, you should not name them like this. These are confusing sometimes. So I just name this like this, DC. Okay, just interrupt everything. Let's see whether everything works now. Car object, my cars. I want to sell the uh, third one. I want to decrease, and I want to decrease the third one by 100 or 1000. What does it have? Okay, so greater than, not supported between instance of function and int. So where does it breaks? See, these things here, see, decrease and decrease, same function, same name. So this is where it breaks. We should keep them separate. Otherwise Python will get confused. Okay, whether it's the function name or it's the data. Okay. Anyway, I guess you also saw how to not define a class now, right? So you should not name your function names and the variables
exactly same. And then Python will get confused which one is the function name and which one is the variable. Let's say 1000. Yes, so it executed properly, and now it is, from earlier it was 34134, now it is 343134. Okay, so anything I can let's say sell. Let's just check sell once whether I can sell this one. Third one, it's already on rent, so I should not be able to sell it. Yeah, cannot sell it. Fine. Now my implementation wise, which one seems to be easy for you? Can anyone just unmute and say? In implementation wise, whether this class implementation is easy, or the whole keeping a separate data structure, or and passing the data structure all the time, looping the data structure within that thing, everything, this one is more easy, or just have the whole thing implemented within that class and just use them whenever you are using or like whenever you are trying to modify some object, you just access it, directly call that function on it, that by dot rent or dot sell or dot decrease, whichever, which implementation you think is easy,
Class.
right? So this is what classes brings, that you don't have to track the data separately, the data will be tracked within the object itself. Okay.
Okay.
Okay. So any questions or any doubts till now? So now I guess you have a good understanding of what classes are, like classes mean, and how to basically use them for a project. But anyway, so it takes some time to like stay in your mind how to or when to use classes and how to get benefit from this the object oriented programming thinking. But anyway, so it will take time. But anyway, I guess for the next weeks or so, we'll be discussing problems on how to like efficiently use object-oriented programming and all. So we'll be used to it by some time. Okay.
Okay. So basically, there are init and
Yeah.
like the two functions you told, they are the
These
ones
are,
inbuilt in Python,
yeah, exactly.
represent and
So these are
so
special functions.
there's another one that I've seen in some codes. Main is written.
Yeah.
Main.
Yeah, so that's something else. That's actually the context on which you are running the program. So there can be separate context on which the program is currently in. It can be in the main function. That function can be so the program can be also executing with a function or with a user defined function, right? Then the context is changed. So main is actually whatever you write outside, and whenever it, let's say, calls a function, it changes its context from main to the function it's calling, and after it gets returned from that function, it again comes back to the main context. Okay, so main underscore main. So this thing I guess you have seen, underscore name underscore is equal to underscore main, right?
Yes, yes.
Yeah, so this is, see, let's just check when print in main. Yeah, I am in main. Now if I just write it within a function, I can see, and also write it here outside as a main function. Okay, so in main, so in main within function. Okay, so this one also get printed. Okay, so now I am confused. I usually thought that these are context switches. Okay, um, so wait, so the okay, I remember. So this main is the main process. So whenever you are creating a sub process from a function, so main is basically the parent process that is creating other processes. So now I remember, this is not the context, this is actually process. main Python. Let's just see what this say. Yeah, so basically this is the main module. Okay, so I use this name in multi-threaded programming actually earlier. So whenever I want to create a new thread, I will check whether it is only getting created from the main function or main program, and any other child process doesn't create its own child processes. So that's how I used to track
It
it. But
is
okay,
also a predefined one like init and represent.
yeah,
It's
exactly. So this dot name is actually defined. Now see, now I can also create a context like this type of thing like here. So let's just create a library. Okay, so libraries are general py files, library dot py. Okay, and it has a function called, let's say, print hello. Okay, print hello. Now this is the library I have. Now I can import the library here, or let's say import, because it's at the same directory. I can directly import like this. Now that library also have a name, which is library. You see, so that also used as a package name also. So main is the main package name. So if I just write this, it prints the main. So whichever current window I have, that package name. So I am currently at the main. Now if I have this library dot name, it should be the library name because it's in the library's context. So by checking whether let's say I want to create a sub process, I should not create it from the context of the library. I should only create it from the main context. So then we can check if I am within the main context, or let's just see. Wait, here if I print name, and outside if I print, so print, sorry, library dot, sorry, library dot print hello and print name. See only, so why does this doesn't get printed? Okay, it's none in that dictionary, in the library itself it's none actually. Okay, hello and then mean. Okay, so but anyway, you can check the, let's say, context of a library or any other sub process and all by accessing its dot name parameter. So you just don't think about these things. So these are only useful whenever you are doing some multi-threaded programming, to check if some other thread is not accessing the data from main thread. These type of checks are only implemented by this type of special variables. Okay, but anyway, for the class, this init or representation, everything, these are standard or pre-implemented functions on the object class, which you directly import whenever you are getting an object. You directly import all the, like this init, representation, other functions, special functions too. I'll tell what are the other special functions when we implementing a coordinate system. So I guess in the next class we'll be implementing a coordinate system, and let's say have two balls collide. Let's say if a let's say we implement two classes, a ball and a bat, and if they collide, there will be a sound. Okay, there will be a tick sound which will be played in the ID itself, right? So you can do these things as well. Okay, so I can also play some sounds within some member function. So whenever, let's say, something happens, a sound gets played. Okay, some animation gets shown. Okay, these things can be also implemented. So we'll see like which are other special functions. For example, this underscore underscore add, this is a special function. Underscore underscore MUL multiplies a special div. This is also a special. So these are all addition, multiplication, division. So you can add two objects. You can divide two objects, but you have to implement the logic. How to add two objects? You have to implement the logic. Okay, let's say you have two coordinates. You want to add them, vector addition. So you have to write the vector addition logic. Okay. Any questions?
So these add and divide, they are also predefined.
Yeah. So why they are predefined? So that you can use the plus operator directly. You don't have to do underscore underscore right whenever you are adding two objects. You can just do b1 plus b2. That would call the underscore underscore add function for you. So Python knows that whenever you are applying plus operator, it should call the underscore underscore add function. That's why they are predefined. No, this is not week 8. So I guess we chose to like to kind of explore object oriented programming because it's now the correct time to learn it, because you already know functions, you will already know recursion and everything. So it's better to know how to do object oriented programming. Okay. Yeah, and we'll touch upon the week 8's topics I guess on the next week. Okay, so now you have something new in your arsenal, right? So you can think in an object oriented way. I don't have to always represent my data in a dictionary or in a list. I can also, let's say, if it is possible, I can also create a class. So let's say I want to track students, right? We already did that. We already did like a problem on how to track student names, their roll numbers and everything in a dictionary. So you can, as a homework, you can always do a student class implementation and check whether that is easier than what we did before. Like the code is small, the code is more readable, right? The class already have all the variables that should be there inside it. So understanding a class is far easier than understanding a functional program. Okay, where the data structure is somewhere defined at the top of the program, and let's say the member functions or any other operators operands are defined at the bottom, right? To associate that, you have to go through the code very rigorously. However, for object oriented programming, because the classes and the data structures are already within a class, so understanding and reading that thing would be very much easier for anyone. Okay, and the implementation should be also easy. Okay, so I guess yeah, you have a pretty good idea about classes for now. I guess we'll see. So I don't think classes will be there in the course material, but it's something new you can add, right? It's not always we have to follow the course material. It's good to know something new as well. So we'll stick back to the course material from next week. Okay. So any other doubts or any other problems you are having with the assignments, you can ask me now. So this is now a doubt clearing part. So any problems you are facing with the assignments, anything you think is correct but it's not showing in the answer scripts, I can just report it to the respective tier. And did that problem get resolved, that some of you are not able to pass a third test case, however the problem implementation was like okay, so it was passing in offline, but whenever you are running it on the nptel or submitting it on the nptel test case server, then it's failing. So is that get resolved or it's still open? No, I think that gets resolved, right? Otherwise you'll okay. Okay, so I'll share this code and I'll share the presentation as well. So I'll put some code here, whichever I did today, and record the, and also upload the recording on the YouTube. Okay. Okay, guys.
Thank you.
Okay. See you. Bye bye.
Bye, sir. Thank you.
Bye bye. Yeah.